All right, section 12.5, partial fraction decomposition. All right. Kind of go, number one thing you want to make sure that you're doing here is make sure that the fraction is proper. What's it mean to be a proper fraction? Small. Yeah, the top is smaller than the bottom, like degree-wise, because this is going to be polynomial fractions. So make sure that the degree of the numerator is smaller than the degree of the denominator. If it's not, then you're going to use long division to break it down some. Okay, so make sure it's proper. Degree of numerator. This doesn't happen all of them that you're going to see are already in proper form, but just you got to make sure of that. The degree of numerator is less than the degree of the denominator. If it's not, use long division. And we'll look at something like that. All right, so we're going to take an example, and I'm going to kind of build you through some steps. So this step one is to check that first on the problem. So,
teachers, pardon the interruption. Caitlin Lucy, Austin Mayfield, Spencer Hurst, and Caitlin Reed need to report to the library, please.
All right, so here's our first example that we're going to use. We have 5x minus 1 in the numerator, and the denominator is x squared plus x minus 12. So we're going to check that first thing. The first thing we check is make sure the degree of the numerator is less than the denominator. This one is, because the numerator has a degree of 1, the denominator has a degree of 2. So that fits the proper fraction idea. All right. Now, the first thing you want to do after you've done that is factor. So number 2 would be factor the denominator. And start off with a pretty easy one here, because that's a trinomial. That's pretty easy to factor into x plus 4, x minus 3. Okay, so first step, make sure it's proper. Second step, factor the denominator completely, as far as you can. Okay. Then we want to make what's called, in step 3, the decomposition template. The decomposition template is the key to being able to decompose a fraction. Okay. There will actually be questions on the quiz. I do, like, it's 5 points for the decomposition template, 5 points for the actual decomposition. It's that important. On the final exam, there has always been a problem that asks just for the decomposition template, not to actually finish the problem, just get the decomposition template. It's that important of an idea. So with the decomposition template, what we're doing is we're saying, okay, here's a fraction that was built from different fractions. This one has how many factors in the bottom? 2. So it must have been built from 2 different fractions. Okay, those fractions look something like this. One fraction with x plus 4 in the denominator, plus another fraction with x minus 3 in the denominator. If there were another factor there, we would have plus c with that other factor in the bottom. So when there's some other rules that we'll encounter as we do some more examples here. But this would be the decomposition template for this particular problem. We have the key here is the degree of your numerator on your decomposition template has to be smaller than the degree of the denominator by 1. The degree of that factor is 1. The degree of that is 0. The degree of that factor is 1. The degree of that is 0. When this degree in the denominator goes up, so does the degree in the numerator. And we'll see that as we get to more complicated examples. This one's pretty simple.
So
If this was x squared on the bottom, it'd be a linear piece on top, be like ax plus b. Something like that. We'll see that as we get to a few more complicated ones. That's the template. Okay, that's not the answer, that's the template. Okay. Now, the next thing you do is you multiply the missing pieces. Okay, so what we're going to do is we're going to kind of work backwards to try to end up with a fraction that has x plus 4 and x minus 3 as the common denominator. Which if you're going to add these two, that's what the common denominator would be x plus 4 times x minus 3. Okay, so this fraction doesn't have the x minus 3, so the a gets multiplied by the x minus 3. The b gets multiplied by the x plus 4. If there were more fractions, we'd have more to do. We'll see that as we get to more complex examples. And then we're going to distribute. So that's ax plus 3 or minus 3a plus bx plus 4b. That statement right there, that line, is going to be where we're going to do the next thing from. And that's set up a system of equations. Using the numerator. Our numerator was 5x minus 1. The original one from the original problem was 5x minus 1. So what we can do is when we set up this system, we have an x equation and then a numbers equation. All right? The x's equation comes from the pieces in this problem that have x's. That's a plus b.
Teacher, pardon the interruption. Hunter Holcomb, Parker Smith, and Kyle Sims to the library, please.
So when I put these two things that have x's together, they should end up adding up to be how much? 5, right? Two things with x's, a and b, should add up to be the things with x's in the numerator, 5.
So you just take one x and add them together.
That's exactly right. Because these are the variables that we have here. Is the a's and the b's and the c's and d's that we'll have later on. Okay. Then the numbers part. Look at this line here, the part that doesn't have x's. You got a negative 3a, you got a positive 4b. So negative 3a plus 4b should add up to be negative 1. A and B will be numbers. Well, we're going to solve them. They're variables right now. But we're going to solve this system of equations for A and B. No, that's a minus 1.
No, negative 3 plus 4.
Negative 3a plus 4b. They're not like terms. Can't put them together. This is an A, this is a B. That's not like terms. They're different variables.
So with the x's, you take the x's off, but with the numbers, you leave everything off.
No, these variables are still here. This is A
I
and
mean, you take
and
the
B.
x's off.
Yeah, there are no x's to take off for those.
All the a and the b out of the problem.
Right. So the coefficients there, yeah, A plus B is equal to 5. Negative 3a plus positive 4b should be equal to the plain number. Okay. The variables are A and B. That's the variables that we're trying to solve for with this system. Okay. Now, since that's a system of equations, we've got some easy ways to solve systems of equations, right? How do we solve that system? That's one way. So if we did a matrix with 1, 1, 5, negative 3, 4, negative 1, and then did RREF to that. That gets us 1, 0, 0, 1, and then what? Graphic calculator. I'm going to go to matrix, edit, make it a 2 by 3. Yeah. 1, 1, 5, -3, 4, -1.
So you all use those
And then want to do RREF. Matrix A. 3 and 2. So A is equal to 3, B is equal to 2. And then you just go back and the final answer is the decomposed fraction would be 2 or 3, excuse me, A was 3 over x plus 4 plus 2 over x minus 3. And that's just going back to your decomposition template and filling in A and B that we had. So by setting up this matrix, we can solve for what A and B are in the decomposed fraction. Now, where's this useful? Really more useful in a calculus-based area, like if you wanted to take the derivative of something. And a smaller fraction is easier to do than one that's more complex. So if you could split that complex fraction up into two easy ones is a lot of times harder or easier to do than one hard one is.
Step 4, did you take the template and just cross multiply?
Basically, on that one I did because I multiplied by what would get me a common denominator. This fraction needs the x minus 3, so that's why A got multiplied by x minus 3. This fraction needed x plus 4, so that's why B got multiplied by that. It's not necessarily cross-multiplying because we're going to get to some that have more than just two fractions in them. But that's the idea. All right. So let's look at another one. Example B. X over x squared minus 5x plus 6. We're going to decompose this fraction. So the first step is to do what? Factor the denominator. So the denominator on this one is going to factor to be x. Multiply to be positive 6, has to be negative 5.
X plus 2 and x minus 3.
Yeah, x minus 2 and x minus 3. Negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. Doesn't necessarily matter which order you put those in, but you got to be consistent as you go through your problem. So if you put the x minus 2 first, always put it first. But it doesn't matter what order you really put them in there. Okay. Now the decomposition template. So we'll call that the DT. Would be two fractions on this one because we only have two factors. X minus 2, x minus 3. The degree of this is 1, so the degree of the top should be 0, so that would be just a plain A. The degree of this is 1, the degree of top should be 0, so that'd just be a B.
What do you mean? What if the bottom was a degree of like 10?
Then the top would be a linear piece, like AX plus B. We'll get to one like that in just a second. Whatever the degree of the denominator is in each part, the numerator's got to be less than that. Okay, so there's our decomposition template. So that means the problem that we're going to work has A times x minus 3 plus B times x minus 2. And
Teachers, pardon the interruption. David Hazel, Dawson Holland, Gage Luke, Mason McCann, Amy Reed, Casey Duncan, and Abigail Wilson report to the library, please.
just go to the room they're in and get them. That's what they need to do. Just interrupt my class. All right. So this fraction would need x minus 3, so we multiply the top by that. This fraction would need an x minus 2, so we end up multiplying the top by that. The denominator, we're not worried about. We already know what the denominator of the original fraction was. Well, that's the common denominator. That's what we're going for there. Okay, so what's missing from each individual fraction? And then multiply that out. It's ax minus 3a plus bx minus 2b. And then set up your system of equations. So you're going to have an equation. The numerator that we're dealing with is just x. So when we look at our problem, we've got an x equation, and then we got a numbers equation. The x's, what's the equation for the x's? A plus b equals 1. For the numbers, good job. Matrix 1, 1, 1, -3, -2, 0, and solve that system. If you want to use a matrix to do that, that's fine. You could use any other method for solving a system.
On the x equals 1, because x equals 1.
It's because the coefficient of x is 1, is where that 1's coming from there. There's a 1 in front of the x understood to be there, so that's where this 1's coming from.
Alright, it's 0
Because there's not a constant hanging out on the end. That's the one that's equal to 0. Okay. You have to use every part of this piece here. So, if there's something missing from the original numerator, then that equation is going to be equal to 0. But this one didn't have a plain number, so that's why we put it equal to 0. Okay. All right. When we run RREF on that, we get A is equal to what? No. -2. And B is equal to 3. So the decomposed fraction would be -2 over x minus 2 plus 3 over x minus 3. And that's the decomposed fraction. It's not bad so far. Well, we're going to obviously get to more complicated than factoring a trinomial. That's algebra 1-ish. So we're in college algebra, so it's going to get. There's the numerator. I mean, you've got these two pieces. They're plain numbers. There's nothing there for plain numbers, so nothing in math would be 0. So that's where this 0 comes from. All right, let's look at a more difficult one. 3x minus 5 over x cubed minus 1. So let's factor that denominator. Hopefully you remember that that's a difference of cubes. And hopefully you remember how to factor a difference of cubes.
Well,
So that'd be x minus 1, x squared plus x plus 1. So again, we only have 2 factors, but the second factor is quadratic. So that changes the game just a little bit. Just a small amount. So our decomposition template,
Pardon the interruption, teachers. At this time, I need the following students to report to the library: Josh Butler, Chad Stackins, Gary Cook, John McAfee, Johnny Rezanuski, Keyshawn Trice, Parker Herndon, Ryan Reichert, and Jonathan Ross. Please report to the library at this time.
Okay, so our first fraction, the x minus 1, that's like what we've been doing. We got degree of 1, degree of top is 0, so that's just plain A. Here we have a quadratic in the denominator. So our numerator needs to be linear, or degree of 1. And when we write a linear equation, what does it look like? Mx plus b, right? So here we used a, so the next letter we're going to use is b, so it'd be bx plus c is our numerator. Degree of the denominator was 2. This is degree of 1. Okay, so if you're going to use something with degree of 1, it has to be like in slope-intercept form is where that's coming from, okay? So that complicates things just a little bit because now when we go to set up our system, we've got to multiply the a times that quadratic. And then bx plus c times x minus 1. So a little bit more algebra involved here. Not much, but just a little bit. So that's going to get us ax squared plus ax plus 1 plus bx squared minus bx plus cx minus c. Or 1a, that's, sorry, got that as an a. So distributing the a to those gets this. FOIL method, distributive property, whichever way you want to think of that. Bx times x is bx squared, bx times -1 is negative bx. C times x is cx, c times -1 is negative c. Okay?
Why didn't you do x squared? Excuse me, x plus a.
Wow, where would I do that?
I thought you said just plus 4.
It's got an a on it. No, not really. All right, so you'd have an x squared equation, which would be a plus b equals, now our numerator, remember, was 3x minus 5. How many x squareds are in that numerator? None, so 0. So that whole thing's equal to 0. Your plain x's, I got ax minus bx plus cx. So a minus b plus c equals how much? 3, because there's 3 in front of the x in the numerator. And then our numbers, we got a and then a minus c, and that's equal to -5. So there's our system that we could,
You don't even bring the variables in with the x.
right. So 1, 1, 0, 0, 1, -1, 1, 3, 1, 0, -1, -5. So that's the matrix that we could use to solve that. And do RREF with that and tell me what's what. What's A? Well, that's already got that done.
Where did the 0?
It's where,
The fact that there are no x squared, this is the original numerator. There are no x squareds in there. So the things with x squareds in this should add up to be nothing. They should be 0. That's where that 0 is coming from. Hey, Jim, come on in.
Do we check that anymore?
Do one now.
Do we have to check that anymore?
What do you mean check what?
Check to make sure that it's 0?
Yeah, look at your original numerator, and if there's not a piece that has that on there, then it's equal to 0. All right. So anybody got that RREF kit?
Yeah.
What you got? A is what?
-2/3.
-2/3. B is
2/3.
positive 2/3
and 13 over.
and 13/3. It's okay that they're fractions. That's you know, it's a number. That's all that we're looking for. So our decomposed fraction would be negative 2/3 over x minus 1. That's the A. The bx plus c would be 2/3 x plus 13/3 all over x squared plus x plus 1. Now, that looks awful because it's fractions inside of fractions, and that doesn't work. See, Cole? All right. All right. So the trick to getting that taken care of is just drop the denominator to the denominator so that it becomes negative 2 over 3 times x minus 1. And since those are both 3's, if they weren't the same denominator, you get a common denominator and then bring it down. Since they're already common, it'd be 2x plus 13 over 3 parentheses x squared plus x plus 1. And then that would be the official final answer on that. Is that. So if there's a fraction in the numerator, just drop the denominator down and put it outside the parentheses and it works out for you. All right, let's look at another one. A little bit.
So are there ever gonna be any whenever, you have to look at this all zeros on the bottom? You have to start like the matrix?
No, you will not have any that will have infinitely many solutions or I guess it's possible that you would have no solutions, which means the fraction won't break apart at all. That's possible, but it's not likely, and you're not going to see that in here. All right, so a little bit different one here. We got x plus 2 on the top, and then x cubed minus 2x plus x in the denominator. So we want to think about factoring that denominator. So I know it's got a GCF of x. And then that will factor as what? That trinomial here, x squared minus 2x plus 1. Yeah, x minus 1 and x minus 1. And that's x plus 2 still on top. So I'm going to rewrite that as x minus 1 squared, like that, okay? That's the way you want to rewrite that. Because that's how you would normally write that anyway. Okay. Now, decomposition template. A over x. So that's taking care of that. Now here's where it gets a little bit more interesting. Because we have x minus 1 repeating, then we have to build up to the x squared, or the x minus 1 squared. So x minus 1, is it linear? Not the squared part, just the x minus 1. Yes, x minus 1 is linear. So the piece for that would be b over x minus 1. And then this is what you have to do when you have a repeated linear piece. It's a linear piece repeated. So it's x minus 1 again, but it's squared this time. But that doesn't change the fact that this is a linear piece. So we're going to put a C up there on the top. The x itself in the factored form is not quadratic. The factored form, it's a linear piece that happens twice. Right? Y'all understand that? The difference in this and the previous problem.
If it happens twice, why do you write it like that? Like, it looks like it happens 3 times.
It does look like it's happening 3 times, but the common denominator would still be this, even though we've got 3 fractions here, because this already has one of the x minus 1s. It doesn't have. This one has 2 of them, but this one already has 1. So what you're doing is, if this was a 4th power here, you'd have to build 1, 2, 3, 4 to get it to decompose completely, spread out all the way. You've got to build up to whatever the degree is on that. Okay. You got to build individual pieces. All right, so there's our decomposition template. Let's build our equation part out of that. So the A needs what? X minus 1 squared, okay? The B needs what? X and X minus 1, that's right. The C, just X. That's the easy one. Okay. All right, so the common denominator would be X minus 1 squared. This fraction already has the X, so it needs both of those. That's why it gets that. This fraction has one of the X minus 1s, and it needs this X and another X minus 1, so that's why it's got X and X minus 1. This one already has the X minus 1 squared, it just needs that X there. And that's coming from that factored form that we got. So multiplying that out, we get AX squared minus 2AX plus A. Because we know that X minus 1 squared is really this, right? That's AX squared negative 2AX positive 1A. And then this would be BX squared minus BX and then plus CX. Now our numerator was X plus 2. But how many equations are we going to have? 3, because we got X squared, we got plain X's, we got plain numbers. All right, so the X squared equation, A plus B equals 0. The plain X equation, negative 2A minus B plus C equals 1. The numbers, A, and there are no other plain numbers. So A is equal to 2. So that means if A is equal to 2, I'm not even going to do a matrix on this one. Because if A is 2, what does B have to be to add to be 0? Negative 2, that's easy. And if I've got 2 of them, I can get the third one, right? 2 out of 3 ain't bad. So that's negative 4 plus 2 would be negative 2. Add that, so that'd be 3. Just by, here they gave us they threw us a bone here. If you want to go ahead and put that in the matrix, an RREF with that, perfectly fine. It still gets you these 3 answers. But you can solve it without it on this one since they gave you one of them. Technically, you can solve them all without the matrix, but it doesn't have to be done. So it works out great. They're not fractions, so we don't have to worry about that. So we go back to our decomposition template, and we just replace the A, B, and the C. So 2 over X is negative 2 over X minus 1 plus 3 over X minus 1 squared. And there's our decomposed fraction. All right. Yeah, and replace what the letters equal. That's all you got to, at the end, that's all you should have to do. At the end. All right, let's do another one. X cubed minus 8 over X squared, X minus 1 cubed. Make it a tough one. All right. So, what's the degree of the numerator? What's the degree of the denominator? 5. Okay, so is that proper?
Yes.
Yeah, numerator is smaller than the denominator. Right. So, next thing would be, do we have to factor the denominator? Is there anything that needs factoring there? It's already been factored. It's already factored, so we don't have to factor it. Yay! One less step. Okay, so we can go ahead and start our decomposition template.
So the we possibly have to do that?
No, you will never have to factor the numerator. Unless the degrees are the same or the top is bigger. Then you might want to factor it and see if you can get something to cancel. That'd be the only time, but you shouldn't
So
have
if
to.
it doesn't cancel, then it should stop.
You have to do long division then. That's what we said back at the beginning. Again, that's not going to come up hardly at all. But I have to tell you that that's what you would have to do. Because what if it did come up? All right, so let's look at our decomposition template for this one. So we got x squared, but that's really x happening how many times? Twice. So we're going to build it up. A over x, b over x squared. And then we got x minus 1, which is what kind of factor? Linear, and it happens 3 times. So we got to build up the 3 of them. So we start with 1 of them. That's C. And then we do 2 of them. That's D. And then we do 3 of them. That's E. So we have 1, 2, 3, 4, 5 variables this time. All right. Now, there's some things that would benefit us if we did them in the background here as some scratch work, and that would be multiplying out these things, because we're going to have to multiply them out at some point anyway. When we go to multiply the common denominator stuff for all these fractions, we need to multiply those out. So I'm going to go ahead and multiply those out just so that we know what they are. X minus 1 squared, we should know that is x squared minus 2x plus 1. And that would mean x minus 1 cubed would be that again, right? Be multiplying this times x minus 1, which would be x cubed minus 2x squared plus x, and then negative x squared positive 2x negative 1. So x minus 1 cubed is actually x cubed minus 3x squared plus 3x minus 1. That's what that is. We need to know that because when we go to multiply this stuff out. So, what does the first fraction need? It needs another x and all of that. But we know all of that is really that, right? So that's ax times x cubed minus 3x squared plus 3x minus 1. B, and I'm going to scoot that over right further to the left. I'm going to need more room. This one has the x squared, so all it needs is all of that, which we know is this. X cubed minus 3x squared plus 3x minus 1. And then the C, what's C need? Needs x squared and x minus 1 squared, but we know that is x squared minus 2x plus 1. We'll need just a little bit more space. D, what's D need? Needs x squared and one more x minus 1. And E just needs the x squared, right? So it got a little simpler as we went, smaller. And that's the way it should go. The first fraction should need more stuff than the last one does. Now we just need to multiply all this stuff out. So this is where, algebra skill is big. So that's ax to the 4th minus 3ax cubed plus 3ax squared
Mary Madeline
minus
Nelson, I work
ax plus bx cubed minus 3bx squared. Distribute there, put plus 3bx minus b. And then cx squareds. So cx squared times x squared would be cx to the fourth minus 2cx cubed plus cx squared. And then the dx to the third minus dx squared plus ex squared. All right, so it's just distributive properties, all that is. Nothing more than that. Now, how many different equations are you going to have? Well, I've got x to the fourth stuff, I've got x to the third stuff, I've got x squared stuff, I've got plain x stuff, and then I've got plain numbers. 5 equations. So our numerator was x cubed minus 8. So the x to the fourth equation, we get all the stuff that's got x to the fourths. So maybe a highlighter helps. There's x to the fourth, and there's an x to the fourth, and that's it. So that would be a plus c should be equal to 0. X cubes. There's an x cubed, there's an x cubed, there's an x cubed, there's an x cubed. So there's a, b, c, and d. So negative 3a plus b plus c plus d. Whoop, hold on. Minus 2c. Sorry. Minus 2c plus d is equal to, what's x cubed? 1. There's one of those in my numerator. So that's why it's equal to 1. And the next thing we need are x squareds. So we have 3ax squared, negative 3bx squared, cx squared, negative dx squared, and positive ex squared. A lot of x squareds. 1 from every variable. So x squareds. 3a plus b plus c plus d plus e. Oh, hold on. That's a minus 3b. Sorry. I'm looking at the wrong colors. It should be minus d as well, yeah. Sorry. And there, how many x squareds are in the numerator? None, so it's equal to 0. I could see a matrix being very useful for this one, maybe. Come feel that and tell me if it's no, mine's not. Jimmy, come in here and look at it. Oh, gosh, fingers. It's not cold. Mine's not cold. That's a good idea. All right, so let's get the x equations. So we got negative a, positive 3b, and that's all the x's. Or none of those. The numbers. We got a negative b, and that's it. And that's equal to negative 8. Hey, we're going to get b for free. So maybe we could do this without I could do this without a matrix, but if you want to do it with a matrix, that's fine. So you got a 5 by 6 matrix. You do RREF on it. You get A, B, C, D, E. I know B is 8 already. Just because this line down here tells me that. No, it's negative b is equal to negative 8, so b is equal to 8. And then that would be 24, and that would make that 24. So A would be 24. And if A is 24, C would have to be negative 24, because they're going to add to be 0. And then it gets a little bit more complicated after that, because you got negative 72 plus 8 be negative 64 plus 48. Negative 64 plus 48 would be 16, negative 16. 17 would be D. And E would be negative 7. So you add 3 times 24, 72, minus 24, which is 48. Minus 24 would be 24. Minus 17, 24 minus 17 would be 7. And then that's negative 7. So there's A through E. Once you get those answers, and guys, put that in a matrix. I'm doing it without it, because it takes me so long to type one in on the computer. Put that into a matrix, 5x6 RREF, and it should spit out those answers. And then you just go back to your decomposition template up here, and you replace the A, the B, the C, the D, and the E, and the F, or the E. You don't have an F. So A was 24, B was 8, negative 24, 17, negative 7. There's the D. That one's pretty difficult. When you have a repeated term or repeated factor, makes it more difficult. It just makes it long. None of the algebra was over our heads. I mean, it's stuff you've done, but the combination of it all is pretty tough. One more example and we'll be done. This one's not as bad. It still teaches us something, but it's not as difficult. All right. X cubed minus or plus x squared over the factor x squared plus 4 squared. What's the degree of the numerator? No, 3. The degree of the denominator would be 4, because you got x squared squared. Our decomposition template for that is going to have x squared plus 4 and then x squared plus 4 squared. If it's quadratic, that means the numerator needs to be linear ax plus b. And then the next one needs to be linear as well, cx plus d.
So that has X, any kind of X on it.
No, if it's x squared, it needs to be linear on top. If it's x to the third, it would need to be quadratic on top, which I don't think you'll get in any of those. It'd be that large. That's a pretty large problem for that to need to be the case. Most of them are going back or something. All right. So what does the first fraction need? Another x squared plus 4. So ax plus b gets multiplied by x squared plus 4. But here's what shortens this one up. What's the second fraction need? Nothing, which is a good thing. You ever have those people in your life that are needy? It wears you out, don't you? It wears you out. So this shouldn't wear us out too bad, because all we got to do is multiply out the first piece. So ax squared or ax times x squared be ax cubed plus 4ax plus bx squared plus 4b. And then this other one is just copy straight down. I don't have to multiply it by anything. So remember our numerator was x cubed plus x squared. So I've got x cubed problem, an x squared problem, an x problem, and then a numbers problem. The x cubed problem, well, there's only one piece that has x cubed. It's a. And how many x cubes are in my numerator? 1. A is equal to 1. I already got an answer. X squareds, that should be bx squared there. So we should have a b, and there should be one of those. So b is 1. The plane x's, I have 4a plus c. How many plane x's are in our numerator? None, 0. And then the numbers, I've got 4b plus d, and there are none of those in my original. And again, you can do a matrix. This would be a 4 by 1, 2, 3, 4, 5, 4 by 5 with RREF. You get A, B, C, and D. 1, 1, negative 4, negative 4. I can do that. You already have A and B, so that makes getting the others easy. Because 4 times 1 is 4. C would have to be negative 4 to add to be 0. And then B is 1, so that'd be 4. D would have to be negative 4 to add to be 0. So you can do it without a matrix, but matrix still gets you the answers. And then you just go back to your decomposition template and replace the A, B, C, and D with their respective answers. Now, 1, 1, negative 4, and then I'm just going to change that to minus 4. And there's the decomposed fraction. There we go. All right. So practice problems, page 903, 13 through 46. Make sure you do, a smattering of those. On 47 through 54, do long division first. The remainder is what you're going to decompose because that'll be the only fraction that's left. So do long division first. 47 through 54. Just do a few of those and make sure you do those. So they're not overly complicated. The long division we've done before, so that part shouldn't be a big deal. The remainder is what you'll decompose after you've done the long division. That's why I ask you to practice it.